discussing the module 2 of the Organic Chemical Technology course, and the lecture 3 now we will be discussing about the gasification part, because the coal gasification, that is very important in the utilization of the coal. So, gasification of the coal and the petrocoke and biomass gasification we will be discussing in detail. And so, this is the coverage of the lecture. First, the introduction, gasification of the coal, petrocoke and biomass, why we are going for the petrocoke and the biomass gasification, what are this importance of the gasification of the, then the history of the gasification, gasification in the Indian context, gasification because we are having the surface gasification and the underground gasification also we are doing, process steps in the gasification, various type of the gasifier that is being used, because we started with the fixed bed, now the fixed bed to fluidized bed, moving bed and all other type of the gasifier that we are using. Then gasification in the fertilizer industry, because that was the one of the major source of the fertilizer also before the availability of the naphtha or the natural gas for the fertilizer industry, because we started 2 fertilizer plant based on the coal, that was through the gasification route, or you can say the partial oxidation, and that was at the Ramakundam in Andhra Pradesh and the Talcher, but these 2 units were closed. And so we will be discussing about the gasification, what are the constant if you are going for the gasification route for making of the fertilizer. Then the biomass gasification and co-gasification of the coal and biomass for methanol synthesis. These are the things. Also we will be discussing about the petrocoke gasification, because petrocoke that we are getting from the refinery, that is being used presently for the as a fuel in the cement plant and other plant, but there is lot of scope for gasification of the petrocoke for making the hydrogen or the synthesis gas, and now the Reliance Jamnagar refinery, they are going for the petrocoke gasification. So, we will be also discussing about the petrocoke gasification. Gasification of the coal, petrocoke, biomass and other carbonaceous material to produce synthesis gas has gained significant economic and environmental importance in the recent years. Apart from the coal gasification, which is being used from beginning of the 19th century, now we are also having the petrocoke gasification, which is the byproduct from the refinery. Biomass is a carbon neutral renewable source which is available in the abundance in the nature, and so that biomass that can be utilized for the gasification or for the fermentation for production of the alcohol. That will be discussing while discussing sugar and alcohol, how the alcohol you can get from the biomass. The technology of the gasification of the partial oxidation of the heavy feedstock is quite established for over half century, and so the only thing development that has taken place, because always there is scope of the development in the any process. The technology of the gasification has undergone continuous developments over years to tackle the higher ends of the refinery bottom, petrocoke, coal and the biomass, even in case of the coal, because the ash content that is varying very widely. Now the coal which used to get during the 50s or 60s, that was much better coal. Now the coal quality in many areas that is having the very highest content. Gasification of the coal to produce coal gas goes to the end of the 18th century, when the coal gas was used for heating and lighting purpose. Even in that continuation, that was the production of the producer gas, water gas. Even I remember when I was working in Orient, we are having the producer gas plant in the lime kiln for making of the lime from the limestone. So, that was the actually importance in case of the gasification, that water gas, producer gas, blue gas, town gas, all those things. So, however, with the availability of the natural gas and petroleum products at the cheaper rate, the interest in the coal gasification dwindled during the early stage, because the more petroleum products that was available at the much cheaper rate. Due to the increasing cost of the oil and gas, again there has been continued interest in case of the coal or the biomass or the petrocoke. So, due to the increasing cost of the oil and gas and the availability of the petrocoke, and look for the alternative feedstock for gasoline and petrochemical, interest was renewed in the coal gasification as well as in the gasification of the petrocoke and the biomass. India's estimated coal reserve of 253 billion tons and lignite around 28 billion tons and lignite around 20. Indian coal is mainly non-coking anthracite and bituminous in nature with ash content of over 35% in many of the cases. Coal gasification is now done by the surface and the underground gasification. With the increasing heavier crude, petrocoke production has increased in the petroleum refinery. So, all the refineries they are looking for the utilization of the petrocoke, because you see that there has been continuous upgradation of the refining technology and the capacity. Now all the refineries they have increased their capacity, and so with the utilization of more and more heavier crude, definitely the production of the petrocoke that will increase, and so the petrocoke gasification instead of the reforming of the naphtha, which is now commonly being used in most of the refining for production of the hydrogen, because hydrogen that is one of the major actually the raw material in case of the refinery or the petrochemical in the various pre-treatment processes as well in the process. So, just to meet requirement of the hydrogen we are producing, but in the future in some of the refinery they may have the petrocoke gasification for production of the hydrogen. Gasification of the biomass is also getting interest during recent years because of the availability of biomass in the abundance. Gasification technology offers the cleanest and most efficient way to convert low and or negative value carbon based feedstock to the syngas, because synthesis gas, that is the again from the synthesis gas we can produce large number of the chemicals. The gasification of the coal involves the conversion of coal to high content gas, that is CO and H2, where the CO and H2 that can be separated, because CO that is converted to CO2 during the, and that CO2 we are using for the making of the urea, and hydrogen we are getting for other purposes. So, that hydrogen that can be used in the refinery if you are having the petrocoke gasification, or hydrogen for the fuel cell, because that is also one of the emerging area. Syngas can ultimately replace the natural gas for industrial purposes, electrical power generation and basic raw material to produce chemical and fuel oil. Why we are not using the coal gasification or the biogasification? Because the naphtha, the natural gas that is available, but how long that will last? And so, in order to have the alternative feedstock, definitely the gasification of the coal, petrocoke and biomass that is going to play a very important role in meeting the raw material for the chemical process industry. The commercial success of the gasification technology will depend on the advancement of the technology such as the low cost oxygen production, because here in case of the partial oxidation and gasification we need the oxygen. So, oxygen that is we are producing by separation liquefaction of the air, and so that is the highly energy intensive process in case of the liquefaction of the air and then the separation for the oxygen and nitrogen, and so that oxygen we are using for the partial oxygen for syngas cleanup, because syngas if it may contain sulfur compound. So, the syngas that has to be, because the otherwise if sulfur compounds are there, then that will result in the catalyst poisoning. Cost effective separation of the hydrogen from the CO2, that is another requirement, because that is not C2 but CO2. So, the cost effective separation of the hydrogen from CO2 because CO is converted CO2 and that is CO2, and normally absorption process and various absorbent, new absorbent that has come, and they have replaced the conventional absorbing media K2CO3 which was earlier used for the absorbing of the CO2. So, the cost effective separation of the hydrogen from the gases, that will be very important. As I told you, we are having the surface and underground. Now the recent years there has been interest in the underground gasification also. Gasification of the biomass, why now the emphasis that is being given on the gasification, because of the availability of the biomass independent. Because now the gasification, you will find a lot of the literature, lot of the development R&D projects are going on the gasification of the biomass to produce synthesis gas, to produce hydrogen, to produce methanol, or the fermentation of the biomass for the production of the alcohol. Gasification is the, as I told you, the gasification, because here in case of the carbonization, that was in absence of air, in the gasification that we are doing in presence of oxygen. So, gasification is the process of converting organic part of the solid fuel to the combustible gases of high heat value by interaction with the steam and the oxygen. So, the high heat value of gas may be important from the fuel point of view, but gasification converts the low value fuel to high heat value, and you can have the synthesis gas from the gasification. The feed for the gasification can be the gas and natural gas, but that is actually the term we are not using the gasification, there we are using the term steam reforming, where from the steam reforming of the natural gas or the naphtha that we are getting the synthesis gas. The solid, so we are discussing about the solid part of the petroleum coke, coal, lignite or the biomass for the gasification here. We are not discussing about the gasification or the reforming of the gases or the naphtha. This is about the availability of the coal and lignite, and so why the now we are having more interest for the gasification of the coal. Indian coal is mainly non-coking anthracite and bituminous in nature with ash content, as I told earlier, also ash content of the coal in our country is very high. Gasification of the coal offers as promising source of chemicals as well as liquid fuel, because depending upon the gasification, because now we are also having the fast pyrolysis process, that is the fast pyrolysis of the biomass, so we can get the liquid fuel. The gasification of the coal involves the conversion of coal to high content gas, means that is the CO and H2, and that CO and H2 again, that is what we call the synthesis gas, that is an important source of the many chemicals including the methanol, and from methanol to other value added products we can make, that the methanol to olefin, methanol to dimethyl ether or methanol to polymer. So, this is the history of the gasification, because you see if you see the literature, you will find the mention of the coke, even long back in China they mentioned the coke. But the before 1700 major fuels were wood and the charcoal that was being used, and the even the coke that was in the form charcoal that was getting from the carbonization of the wood. The 1700 to 1750 industrial revolution, coal as a fuel that came in relation with the availability of the coal pyrolysis, town gas supply, water gas, producer gas. Then the cryogenic air separation that was developed in 1920, and so the oxygen that replaces air, and so the efficiency of the that was high. Then the Winkler's fluidized bed gasifier that was developed in 1926, and because the fluidization that came in the big way, not only in the gasification but also in the petroleum refinery with the fluidized bed catalytic cracking and the improvement in the production of the various chemicals. In 1931, Lurgi moving bed gasifier that was developed, and 1940 the Entrained flow gasifier. These were the earlier development that took place, but again there is a lot of changing in this configuration. 1950 Texas and Shell developed oil gasification, and 1970 that was the oil crisis that took place, and then the Texas developed slurry process for coal gasification. 1974 again the Shell and the co-posted pressure gasification, high temperature Winkler, that is the gasification process. So, these are the some of the beyond again Shell gasification. Shell and even the Reliance, they are working in big way on the gasification, because that is going to have the future source of the synthesis gas when the resources of the crude oil that will be less and less. Wood gasification, as I told you earlier, because it was the wood from where we are getting the charcoal. So, that was the earlier route for making of the naphtha also. Naphtha, both the process that has been reported, either the steam reforming or the partial oxidation of the naphtha, that is the in the Indian context I am discussing earlier. What are the development we discussed in the gasification, that was the global, what are the changes that has taken place. This is how we started in case of the Sindri, because Sindri, that is the place you see the first manufacture of the fertilizer under the banner of Fertilizer and Chemical Corporation, that was started in the Sindri, and that was the, and large number of Sindri is just near to Dhanbad. So, a lot of the coal that is available there, and the another, as I told you, the coal gasification or the coal partial oxidation, that was the same under the FCI banner that was started in the Talcher and the Ramakundam unit of the fertilizer. So, Winkler fluidized bed for lignite is the Naveli, Texco, Naphtha, Fact, Cochin, that is the fertilizer and chemical Travancore. The fact, that is the plant which is making the fertilizer, urea, as well as they are making also the caprolactam, that is one of the raw material, the monomer for the making of the nylon 6. This is the, I told you earlier about the Ramakundam and Talcher. These were the two processes which came into existence based on the coal gasification or the coal partial oxidation. But again the unit has to be closed, because lot of the cost of production of the synthesis gas from the coal is higher than the what we are getting from the natural gas or the naphtha, because earlier the naphtha gas availability was less, but with the coming of the HBJ pipeline and other pipelines for the natural gas and the processing of the your crude oil, more and more processing of the your crude oil from the offshore, onshore, and at the same time with the availability of the natural gas from the your KG basin. So, that affected the operation of the coal based plant. But again there is as I told you the interest, and the lesser part in some of the fertilizer, especially the NFL, they started using the fuel oil, because most of the plant of the National Fertilizer Limited NFL, they are based on the fuel. Again they have shifted from the fuel oil, even the your IFCO plant at the Pulpur, that was based on the fuel oil. Now again all those plants they are shifting to the more cheaper raw material, means the from the petroleum route, that is the naphtha or the natural gas. Again the NFL, Bhatinda, Panipat, which I told you, they started using the fuel oil, because at that time the huge amount of the fuel oil that we are getting from the refinery, and there is no use except the fuel, as a fuel you are using. So, the some of the fertilizer plant, they were based on the fuel oil. So, as I told you, the gasification, that can be underground gasification or the surface gasification. Underground coal gasification, gasification of the coal happens in situ by controlled burning. About 35 cubic meter of gas can be produced per ton of the coal. Byproducts of the significant importance are hydrocarbon, phenols, anhydrous ammonia, and the clean water. So, this is the some of the byproducts that we are getting from the, not the clean water, but the water we are getting. UCG overcomes the hazard of the underground and open cast mining, and as slag removal is not required as they remain in the cavities. So, this is some of the advantage why we are now going for the underground gasification. Some of the advantage are the tapping of the energy from vast coal reserves which are not economically viable to mine. In that case, the underground gasification, that is very important. Increase worker safety, low environmental impact, increase worker safety, that as I told you, and that is because of the underground gasification. Surface gasification involves reaction of the coal with hot steam and control amount of air or oxygen under high temperature and pressure, which produces the synthesis gas, which can be used for the substitute of the natural gas for power generation, using low B2 gas as fuel, manufacture of chemicals and fertilizer, and conversion to liquid fuel by GTL technology, gas to liquid technology. Because gas to liquid technology, that is coming in a big way to utilize these heavier fraction for producing the gasoline. So, GTL technology, gas to, that is based on the Fischer-Tropsch synthesis. Process steps in the gasification. Some of the process steps involved in case of the gasification. First part is the feed preparation, then the gasification. Gasification in the presence of air and the presence of oxygen, because many of the plants they are having the air separation, because if you are having the oxygen, that is always better. And so the syngas cooling, because synthesis gas which you are having there, that has to be further process for the separation of hydrogen, for the conversion of CO2 or in other process just like for the methanol synthesis. Air separation, as I told you, that is the one of the very important unit of the any plant which is based on the partial oxidation or the gasification, where oxygen we are using for gasification. Acid gas removal, again acid gas, that may be because of the simple compound present in the coal or even the petroleum coke, because you see the petroleum coke, how we are getting more petroleum coke because of the your heavier crude oil, and the heavier crude oil they always contain higher sulfur than the your other crude oil. So, the acid gas removal even in case of the coal gasification or the petrocoke gasification is very important. Slag handling system. This is the process of the gasification, whether you are having the coal, petrocoke or the biomass, that will go to the gasification, steam, oxygen, that will go to the gasification section. Gas purification, sulfur useful byproduct, because always whether it is the refinery or the other plants or even the NFL Panipat or any fertilizer plants which are using the heavier fraction, they are going for the recovery of the sulfur and by class process or the modified class process. Then from the gas purification, that will go to the synthesis gas, which the synthetic gas, that will be actually because you know the synthesis gas means Cu and H2 for the various manufacture of chemicals, or it may be hydrogen and nitrogen. If hydrogen and nitrogen is there, what we are doing? We are using this nitrogen from the air separation unit in the ammonia plant for making the hydrogen which we are getting from the syngas, and the CO which is remaining after the separation of the hydrogen, that is being used CO, that is converted to CO2, and that CO2 along with the ammonia we are making the urea. But if you are having the CO, because CO is also important source of the a large number of the chemicals, and already and some of the things we discuss in the earlier lecture, but again we will be discussing in detail by discussing the synthesis gas and the various chemicals which are getting from synthesis gas in the while discussing the petrochemicals. Hydrogen chemicals, hydrogen and the chemicals mean methanol, that may be important product, hydrogen that can be used in the process for making the ammonia, or it can be used for the fuel cell, or it can be used for other purposes, various hydrogenation process, hydrodesulfurization process, clean syngas for refinery use, synthesis of the hydrocarbons, power generation. So, now let us discuss what are the in detail about the various steps in gasification. Feed preparation, wet feed system or dry feed system may be used in the gasification. Wet feed system imply grinding and slurring with the water and pumping to the gasifier, while dry system consists of grinding of the feed and empty log hoppers to pressurize the feed. And so always the dry actually the raw material that will be the more economical than the the wet feed. Then the second part is the gasification, that is carried out at the 900 to 1100 centigrade. Carbon react to the oxygen and steam to form the synthesis gas. Synthesis gas, there is Cu and H2 and some minor byproduct which is removed to produce the clean synthesis gas, which can be used as a fuel for generation of steam, electricity, or it may be used as a chemical feedstock like methanol, and methanol to again we can go for the manufacture large number of the chemicals like the formaldehyde, or it may be methanol to olefin or methanol to plastic. Then comes the other steps, syngas cooling. High temperature syngas produced from the gasification, that is cooled, because always the wasted boiler, that is integral part of the your gasification plant, or the steam reforming, where we are recovering the heat from the gases, and so the steam is generated. Then the air separation, this is only normally wherever we are having the steam reforming, we are using the air directly, but in case of the partial oxidation process or the gasification, we need the pure oxygen for gasification. So, the process is based on the cryogenic separation of the air. This is the mostly we are using, although the pressure swing adsorption that has also come for the separation of the oxygen nitrogen, but mostly all the units they are having the air separation, and after that the pressure swing adsorption that was developed. The process involves liquefaction of air and fractionation to get oxygen, nitrogen and other gases, because the large number of the other inert gases also we are getting from the air separation. Acid gas removal, this involves the removal of impurities like H2S, COS, NH3 and HCN by absorption using various commercial solvent like monoethanolamine, methyl diethyl, because as I told you, for absorption of the acid gas, these are the some of the development that has taken place, because with the coming of the petrochemical complex, now we are getting the monoethanolamine or dimethanolamine. So, these are the some of the amines that are very commonly used even in the refinery and the fertilizer also. Methanol, that also we are using for the even for the absorption of the CO2 in some of the fertilizer plant, where they are making methanol, just like RCF or the NFL Panipat, they are using methanol. And the sodium carbonate, of course, that was the solvent is regenerated by steeping, and the acid gases and the recycle. Slag handling system, this gasifier may be either slagging or non-slagging type. The reaction, it is an exothermic, because always you know the whenever your oxidation is there, that is exothermic and produces a gas containing mainly Cu and H2. And because of this exothermic and the endothermic reaction in case of the steam reforming, now there has been development in case of the reforming process also, that is the autothermal refining. So, where they are using both the partial oxidation and the steam reforming, the steam, the heat generated during the exothermic process, that is being used for the in the endothermic process, that is the catalytic reforming. The raw synthesis gas contains a small quantity of CO2, H2 and H2S and impurities such as These already I have discussed about these impurity has to be removed in the air, that because the argon that is coming from the and the ash. A small amount of unconverted carbon, because during the always whenever the carbon rejection is there, whenever you are going for the high temperature, same thing is happening in case of the partial oxidation also. The carbon is also present as a fine particle and ranges from the 0.5 to 1.0% weight in the liquid feedstock, or 500 to 50 to 200 ppm weight in the gaseous product. These are the reaction that is taking place in case of the gasification, combustion, steam reforming reaction and bound wort reaction. These are the some water gas reaction, water shift reaction, methanation. These are the some of the series of the reaction, because you see the partial oxidation or the steam reforming, that is a complex in nature, a number of reaction that is taking place simultaneously during the process, and this is the reason why we are getting the methane also. Gasification, now we will discuss about the why we are going for the gasification in the petroleum refinery. With the increasing use of the heavier crude and processing of the heavy residue has resulted in increased production of the tar, petrocoke and asphalt by various residues, upgrading technology like visc breaking, coking and despelting, because you see we start with the thermal cracking, then the catalytic cracking, and again visc breaking or the delayed coking processes are now extensively used in all the refinery for processing of the heavier residues we are getting. So, during the process we are getting the petrocoke, because during the coking process of visc breaking, and that petrocoke now because you see you take the case of the Reliance, their capacity plus 60 million tons crude oil processing, all the refineries they have increased their capacity. So, they are processing, and even the crude oil which you are using, the crude oil which you are using, that is indigenous crude is only 35 to 40%, rest it is all imported crude and it is varying in the quality, and more heavier residue, heavier crude oil now it is available in the refinery, and so the mixed, that is the reason why we are using the mixed crude oil for processing. It is not only the imported or the indigenous crude, but it is the mixed blend of the crude oil that we are processing. So, the huge amount of the your petrocoke that is available, and that is going to be available in the future because of the use of more and more heavier. So, these residues can be gasified for production of the hydrogen, syngas, electricity, ammonia and other chemicals. But production of the hydrogen already some of the units they are going for the production of the hydrogen from the syngas. Only problem in case of all the steam reforming or the syngas, that is the generation of the CO2. That CO2, 1 ton of the hydrogen that produces about 10 tons of the CO2 when you are going for the steam reforming. So, that is a big challenge in the refinery, but with the availability of the petrocoke we are going for the gasification of the petrocoke and for the production of the hydrogen, because that is the way, that is petrocoke that is being used by the other plants like cement and the paper unit as a fuel. So, why not the your refinery itself can use that raw material, important raw material, because always the petrocoke is better than your coal, because the carbon content is much higher than the coal, and so the always the gasification or the partial oxidation that will be very economical. Now, let us discuss, because as I told you the gasification or making of the coke, that has been from the ancient time in some or other form. So, we started the gasifier, that was the first gasifier, that was the fixed bed Lurgi fixed bed gasifier, and the fixed bed involved an upward flow of the reaction gases through a relatively stationary bed of hot coal. The gas velocity is slow. Moving bed, Gasifier operates countercurrently where the coal enters the gasifier at the top and moves downwards and slowly heated with the product gas, and gasification takes place in the gasification zone. So, this slowly from the mixed to moving bed and moving bed to fluidized bed, that is the development in case of the gasifier. Fluidized bed gasifier that operates at higher gas velocity than the fixed bed and uses smaller particles. The gasifier operates at atmospheric pressure and moderate and uniform temperature. So, better actually the quality of the synthesis gas, and it is more energy intensive, that is in case of the fluidized bed, and the better reaction is there. So, now the most of the cases, now the new type, even in case of the go for the thermal power plant, we are using the now the fluidized bed water. So, next development in case of the gasifier, that was the entrained fold gasifier. Entrained bed operates with the parallel flows of the reaction gas and pulverized coal, because as I told you, in case of the thermal power plant where you are having the fluidized bed, so there we are using the pulverized coal. So, pulverized coal which minimize the reaction time and maximize the thorough output of the product. The residence time is few seconds, ash is removed as a molten. So, this is in case of the entrained flow gasifier. This is the fixed bed gasifier, coal feed that is going to the coal lock system, and from the coal lock system it is going to the gasifier section, rotating grate for removal, continuous removal of the ash that has to be there, and depending upon the type of the, because if you are having the coal, definitely ash going to be more than the petrocoke. And this is the water jacket is there. Here water jacket is there, it is not shown, but water jacket is there for cooling steam and oxygen that is going to the gasifier of gases, that is there. So, this is the fixed bed, that was the older technology that was being used and that was developed by the Lurge. And then the entrained suspend gasifier, that is the again the new development that is taking place, that is the steam and coal that is going, and this is also the type of the fluidization system is there. This is the fluidized bed, that was the actual the earlier which I showed, that was it is not the fluidized but is the moving bed. This is the entrained and this is the fluidized bed, coal and steam that is going from the bottom, fluidization that is taking place, and the ash that is coming continuously from the bottom of the fluidized bed gasifier. This is the again another type of the fluidized bed gasifier where the fluidization is taking place, and syngas after going to the cyclone where the particulate matters are separated, and then the syngas that will go for further processing. New gasifier designs that elimination of the air separation unit, because as you the cost of the air separation that is very high, and so the now the elimination of the air separation unit is there in the new type of the gasifier. High temperature syngas cleanup, high efficiency and the lower cost. These are the some of the development that is taking place in the gasifier. New gasifier, they have the caviar transport gasifier, which that is developed by the caviar, low rank, high ash, high moisture coal, compatible, that is for the caviar, because always some problem when you are having the high gas coal. For power generation, air can be employed as the oxidant. Here actually the you see the oxygen, instead of oxygen you can use the air. Lower cost predicted, higher availability predicted. Non-slagging and refractory issues should therefore be minimal in case of the your coke oven plant, this gasifier. Higher predicted efficiency, lower emissions, large scale of the technology. By 2010, that was the actually estimate earlier. This technology will be operating at a scale of EGS gas. Experience already in 2007, lower temperature and short gas residence time may lead to the some methane formation, which is determined in the chemical application, because methane that may be inert material in case of, but in case of the chemical, because whenever you are going for the fertilizer plant, we are removing the CO2 by nitrogen, but in case of the steam reforming you are converting this CO to methane. So, but in other application that methane that may be problematic, as disposal problem with carbon conversion prediction are not met in the commercial operation. Again you see the always there has been people have been looking for the better and better operation. So, instead of the normal gasification, now people are also looking for the catalytic coal gasification. So, elimination of the oxygen for SNG objective syngas, little or no catalytic methanation required, high thermodynamic efficiency, catalyst cost and recoverability, carbon conversion methane production else in the gasifier. So, cost of the applying the catalyst effectively to the coal inherently must be done in fluidized bed which have not been scaled up to the larger capacity. So, some of the advantages are there in case of the when you are going for the catalytic coal gasification. Now, we will discuss about the coal gasification in the fertilizer industry, because as you see the coal gasification for the production of the synthesis gas and ammonia has been used many part of the world where large quantity of the coal is present. High energy consumption in coal based ammonia plant has been major constant. Relative energy consumption, if you see the gas, if you take the gas 1, so naphtha is 1.5 times, fuel oil 1.15, coal is the maximum energy consumption when you are producing synthesis gas or ammonia. This for the figure is for ammonia. So, the always the cost of production of the syn gas or the ammonia that is higher, and that has been the major constant in utilization of the coal when we are having the enough gas or the naphtha. But you will have to always look for the alternative resources, because the whatever the resources of the oil or the supply of the oil, the volatile market of the crude oil, definitely you will have to look after the some of the other raw material also. But again government is thinking to start the coal based fertilizer plant. This is another rapid thermal processing for conversion of the biomass to liquid fuels, because I will be discussing about in detail about the biomass gasification here. That's why the importance of the biomass gasification. So, this is the we are doing the fast pyrolysis also to get the more liquid products. So, let us now discuss about the biomass gasification. Why we are going for the biomass gasification? Why what was the necessity? Because the biomass is available in large quantity. And because of that reason, biomass gasification has received considerable interest during the recent years, as biomass is the carbon neutral renewable source, and always we are talking about either for the renewable energy, renewable feedstock, because whatever the resources we are having, that is not unlimited. So, definitely you will have to think of the alternative resources in case the conventional resources are not available. The constantly depleting resources of the conventional energy and the steeply escalating price of the fossil fuel have led to the need of the alternative energy and the raw material resources. This is the reason why we are going for the utilization of the biomass. So, what are the ways of utilization of the biomass? Because there are in the various forms that the biomass that can be used. One is the gasification, where you can produce the synthesis gas, hydrogen and methanol, and the Fischer-Tropsch synthesis for liquid, dimethyl ether production that can be also blended with the gasoline, or dimethyl ether to methanol that we can produce. Another actually the development that has taken place, which I was telling about, the fast pyrolysis of the biomass. Fuel through fast pyrolysis having short residence time and moderate temperature that yield in more liquid products than the gaseous product. So, that is what we are doing in case of the, and again lot of the work that is going on the fast pyrolysis of the biomass to get the more economically, because that is very important. You see the whenever you are using the fuel or the liquid fuel from the petroleum, that is always cheaper. So the fast pyrolysis that has to be processed, has to be optimized. Then the next major use that is coming in a big way, that is the fermentation of the biomass for the production of the alcohol. That will be discussing while discussing the sugar and the fermentation industry, where how the biomass that is being used for the alcohol production. Syngas and the hydrogen and methanol from biomass. Methanol and hydrogen produced from the biomass are promising carbon neutral fuel, and the various process step in case of the biomass, that is the pre-treatment, gasification, gas cleaning, reforming of the higher hydrocarbon, gas separation, and finally it may be methanol synthesis, or you can separate from the CO2, CO and H2, that H2 that can be separated if you are interested for the production of the hydrogen. Then the CO2, again the CO that has to be converted to CO2, and that CO2 if you are not having, so that is a problem. As I told you, about 10 tons of the CO2 that may be produced with the 1 ton of for producing 1 ton of hydrogen in the steam reforming. So definitely you will have to look for some alternative thing. So this is the typical yield of the various biomass if you are having the pyrolysis oil. So hardwood, softwood, hardwood bark, softwood bark, corn fiber, bagasse, waste paper. But actually you see the bagasse or the waste paper or the even hardwood, softwood, normally it is being used in large quantity for making of the paper mill, and so even the deforestation problem, it may not be very economical to have but at least the hardwood bark, softwood bark that can be used even in case of the bagasse, because you see the bagasse that is being used as for the only fuel purposes. Why not to provide the alternative fuel to the sugar mill, so that the bagasse that can be used for more value added product through the gasification or for other or alcohol. Waste paper, again you cannot afford to go for the fast pyrolysis waste paper, because this is also being used for the production of but this is how the availability of the pyrolysis oil is there. Waste paper that is being used in huge amount, and now many of the mills in India, they are totally based upon the waste paper. This is the chemical conversion route for the biomass gasification, that is the biomass gasification, pyrolysis or hydrothermal liquefaction that may be there in the presence of hydrogen. We may get the synthesis gas, that from the synthesis gas we can go for the pre-diesel, DME, dimethyl ether or the methyl, and the bio oil, hydrotreating and refining, then the hydrocarbon that. So this is the process that can be used for the gasification of the biomass. This is the biomass conversion route for the biomass to biofuel. Hydrolysis and anaerobic digestion, this is for the production of the ethanol. Again we will be discussing while discussing the ethanol manufactured from the biomass. Now the recent interest there has been for the coal gasification of the coal and biomass for methanol synthesis, because you see the coal and biomass, if you mix with the coal, so the co-gasification that can be done, and some of the advantage, because in case of the co-gasification of the coal and biomass combined with the power and methanol production can be considered as a potential fuel base for gasification. Some of the advantage of integrated biomass coal gasification system are possible continuous operation of the coal gasification reactor, low cost of the electricity energy production, because as such you see the biomass is that is free, only the transportation cost will be there, and so definitely if you compare the cost of the coal and the biomass, so definitely the whole process that is going to be the economical. So this was actually about the gasification part, the coal gasification, petrocoke gasification or the biomass gasification, and definitely in the future because some of the country like China, they are having the huge amount of the coal deposit. So they are going for the, already they have started one plant for the coal gasification, and from the coal gas to synthesis gas, and from synthesis gas to methanol, and methanol to plastic. So that will be the one of the actually the major area where they still, in India also we are working for the coal gasification for making of the synthesis gas and from the coal route too, because in India also the coal deposit is much higher than in comparison to other country. Similarly, the biomass gasification, although we are not using the biomass gasification in India, but there is a lot of the scope for the biomass gasification, and this is the reason why the most of the multinationals or the even Indian industry, they are getting interest in the utilization of the biomass for the production of the synthesis gas or the production of the alcohol through the fermentation route or as a fuel. Then the same thing is the petrocoke. Petrocoke which we are making, which we are getting from the refinery, that can be again a source of the good source of the, because the petrocoke quality is much better than the coal. So always the cost of the production of the hydrogen or the syngas, that will be lower than the coal. At the same time we will be utilizing that waste material or the byproduct of the delayed coking or the coking plant, or it may be the waste breaker for the production of the hydrogen. That hydrogen that can be used in the refinery for in the various processes, just like the catalytic reforming, hydrodesulfurization. Then hydrodesulfurization means removal of the sulfur compound of the feedstock for the various process. At the same time, desulfurization of the product which we are getting after the crude oil distillation or the just like the diesel desulfurization. So that hydrogen that can be used. So as I told you earlier also, the Reliance, they are going to have the petrocoke gasification. Other uses of the petrocoke, of course, they are there instead of the fuel, that can be also used the for the electrode also, but the gasification part definitely that is going to improve the economy of the any refinery, because now in future we will have the more and more heavier feedstock. So this was the about the. So next module, that will be the module 3, that will be on the pulp and paper making, and so that will have the 4 lectures. Lecture 1 about the introduction of the paper industry, what are the development that is taking place. Lecture 2 will be discussing about the pulping and bleaching, and lecture 3 that will be on the your recovery of the chemicals, and 4th lecture that will be on the paper making part. So this is the how we will be proceeding one by one from the coal to the paper making.